Hello YouTube and welcome back to a new video because, so today I am going to be starting a new series of how to make 3D games in Python with a pyglet. So I don't think there's much else to explain apart from what we're going to do today. So basically today we're going to make the window with just a screen with a certain color. Maybe make it change, have a caption and all that stuff. So I guess that the aim at the end of this series is to make you know how to make games like Minecraft or stuff like that in Python. So let's get right into it. So first thing I'm going to do is import the library that I'm going to use, which is pyglet. So pyglet is a very good library for making video games in general. It has a very good performance and in general it's pretty good and all that. So I'm going to import pyglet, so that's going to import the library. So if you're not familiar with Python, then I guess you should download it so that you can learn how to use this. So this is just Genie. It's the editor that I use to edit my codes, but you could use Notepad if you're on Windows or anything like that. So yeah. So now I'm going to get all the important things from pyglet. So from pyglet I'll import star, which basically means all. Oh, and by the way, this first line of code, it's not necessary. I prefer to keep it. It's better for compatibility, so you can just copy paste it. It's not really Python at all. It's just two comments at the top which tell the interpreter what to do. So now I am going to tell pyglet to not debug opengl. So basically, I'm just going to set this to false, which means that it won't do it. So this basically means that after every single opengl call, which is a library for making 3D images on the screen, and that's what pyglet uses, it will check for an error, but we don't want that because it's very bad for performance, and if your code is anyway well written, then there's no real need. So yeah. And now, next, I am going to do from pyglet import. No, actually, I'll just do import pyglet.gl. So this will open OpenGL. Okay, so now let's start by just making our window class. So this will make us able to use our window. I guess I could put it like that. So this class is type is pyglet window.window. So this will just basically tell pyglet that when I make this window and I initialize it with all my data and parameters to make like the width, the caption and all that, then just say that it's a window to pyglet. And I'm just making this window class, so just for not confusion, because otherwise I'd be having to do stuff like window.event and I could get things wrong and I could get messed up, and it's basically very complicated, so I do class like this. So for every single class in Python you need an initialization so that you can initialize your class, and so what to do when I call this class. So I am going to do self, which will be our global variable name for the inside of the whole class. So every single variable and function that we are going to be using will be with self. So with definitions and functions, you put the self like this and then continue. Otherwise, in this definition, you won't be able to use the window, basically. I guess I could put that like that. So you wouldn't be able to do stuff like, as an example, self.getWidth, because that's part of the window, but if you don't add that so that it's part of the window class, then it won't work. So now I'm going to make some arguments. Now you don't really need to know what this does, it's kind of complicated and it's not necessary to know. So I'll put the same thing in here. So args, no, actually in here I need the class, and then self, and then I am going to initialize it. Then in here I'm going to have the arguments and the wargs. So over here what I'm doing is I'm just letting this know, I'm just initializing it when I'm initializing it, I guess I could put it like that with the arguments. I don't know, it's very complicated. I don't really know how to explain that. But over here you have a self, so this is basically equal to self, I guess. And so in the window class I am going to initialize, I'm going to execute the initialize function with these arguments, which are the ones over here that are passed in here. Yeah. Okay, so now we are going to make a new function which is onDraw. So this is basically when I draw on the screen. So this is an event that pyglet actually passes to my window. And basically all I'm going to have to do in here is do self, which is the window, and I'm going to clear the window. So that means that nothing else will be on the screen anymore. Okay, so now I am going to do, when it's run, so if name equals main, okay, then what I will do is window equals window, so a class up here, so yeah, this class, and I will have some arguments that pyglet's window actually enables me to have. So these arguments will be, first of all, I'll do that afterwards, the caption, which is, let's just call it, yeah, Minecraft clone, because that's what we're going to be doing in the future. And then we're going to disable vsync, and I'll explain what this is. Vsync basically makes so that the frame rate of the window is limited to the frame rate of your monitor. So that's not good for a couple of reasons. First of all, if you're having multiple buffers for clearing, so basically if you have multiple windows and you have to alternate them, and your program is running at has to run at 120 frames per second to alternate on both sides of the screen, then it will be limited to 60, so it will divide it by 2, which will be 30. So basically I make it so that it can virtually get higher frames, but so that you can alternate between them, and it will give the monitor the right amount, and so basically it's to get better frame rate. That's all that you need to know. So now I am going to make a setup function after this, and then I'm going to tell pyglet to run my application with this. Okay, so now I am going to make my setup function. So we don't need anything in here, it's not part of the window, it's just a simple function that we globally call. And all I'm going to do in here is gl clear color, and I'm just going to put a random color, so let's just make blue, and I'll explain what these numbers mean in a moment. So this is our first opengl call, which will basically mean that when I clear the screen it will be this certain color. So normally, if I have not done something wrong here, if I run this, module object does not support item assignment. Yes, I think if I do this, just 2 seconds. Yes, it's the options, so it's pyglet.options that I need to do. So now if I run this, then gl clear color is not defined because I haven't imported all of this. Okay, so from pyglet.gl import star. So this will enable our gl functions globally, I guess. There we are. Look, now we have a lovely screen. This is it's our first screen. So we can make colors, I guess, different colors. Let's just do like this. So this will make, see, yay, a pink kind of color. Maybe we could try some orange. I think this would be orange. Yeah, so this is some orange. What is that? Oh yeah, okay. So now we'll explain what these colors are. So these are some red, green and blue values. So over here they range from 0 to 1. And so the first value is the amount of red that I want per pixel. So this is maximum red, so this will be completely red, and then the next value is green, and then the next value is blue. So if I mix 100% red with 50%, because that's 0.5, so it's 50% of one, of green, and then I mix 0% of blue, then it will be loads of red, a bit of green, so it won't be completely red, it will still have a bit of green, I guess, and then no blue. So if I do something like 0.0, I'm actually just going to comment all this. Okay. Now this will be red because I'm completely red over here. I would have green if I do this. Okay. And then I would have blue if I did it like this. Okay. So this is magnificent. So I think that I have enough time to maybe show you how to make a cube, maybe. So that's what I'm going to be doing right now. So yeah, that might be a bit difficult. So yeah, so let's just show what batches are. So I am going to make a global batch inside of this function. So batch, and the way that I define batches is doing pyglet.graphics.batch. Can't remember exactly. Check on that later. And then I can add certain things to the batch. So if I do like add block to make just a random cube in the middle, and actually, yes, I'm going to make these cube vertices, and actually, no, I'll keep it like this. So this is going to be this is going to be the vertices, so where I'm going to put it, the size of the cube, you know. So I will add a cube to this batch at the position, and then I'm just going to try a color, and by default I'm just going to put this 1.0, 1.0, okay. And in this color, I will, well, in this batch I have to add, first of all, so I'm just going to make some data for the vertex data. I'm going to add an O to make original. Now this is a variable, so it can be whatever you want. And so I am going to make model vertices, and I'm going to put it at, actually, I'm going to make separate variables for X, Y, and Z. Equal to position, and actually I'm going to do self.add block at position 0, 0, 0, and then at this color. What am I doing? And I'm just going to add, I guess, like I know, like a purple color thing. Yeah. Maybe a bit less red to make it less ugly, because otherwise it's going to be such a bright purple, completely I don't know. Okay, so this basically separates my tuple over here into different values. So the x-axis, the y-axis, and the z-axis. So in my model vertices, you can see over here I've got the same thing. So I am going to put the position So here I don't need separately to recombine them. I can just put the tuple as it is. So basically this is the same thing as putting this in here, and that is the same thing as putting, well, each individual value, which is x, y, z. Okay. So now I will put actually no, since they're separated now, yeah, so they're separated, so I do need to do x, y, z. And then I'm going to do the size, which will be 0.5 on each side. So I can see I add n and then I subtract n on the other side. So that basically means, just remove this, so that on one side there will be 0.5, and then on the other side there will be 0.5, which adds up to 1, and that's about 1 meter. So there. Now I have these actually. This code will be in the description, and actually this whole code will be in the description, so that you can follow along. But basically this is each face. So I'm going to have to split them into, well, I'm going to have to combine them in one long string. So I'm sure there are more efficient ways to do this, but the most comprehensive way is to make a for loop. So for face in x range. So x range is the same thing as range, it's just that it's faster with memory. You can look it up on Google, and I'm not going to explain that here. So I have 6 faces in my length, and actually I didn't explain what this is. So lambda is basically the same thing as if I did define model vertices, but it's as a variable, so I don't know, it's a more elegant way to do it, I guess. And then I'm going to do vertex data equals vertex data, plus vertex data original, but it's for each and every face. So you might be thinking why you can't just do something like vertex data plus equals vertex. That doesn't work with strings and lists for some weird reason. I don't know exactly why. Anyway. So now I'm going to go into my batch, and I am going to add so 24. Now this is kind of a random number, but it's basically the amount of vertices, I think, or the amount of values for vertices. So I have 3 axes. Times 4 for each face, times 6, so that makes 3 times 4, which is 12 times 6, and that makes 24. Normally, I can't remember exactly. Anyway, then I would add a group, but I won't. What? Yeah, I will add a group. That's dot group. Just wait 2 seconds, because I need to do the code for. So yes, I am going to now make some textures. We're not going to use them just yet, but just as an example. So I will make a new one, and this texture will be 256 by 256. You'll see later why. It's not exactly important. So I will just make this into a screen, and I will just basically make a texture with a complete, well, this is, well, let's just make this kind of random yellow thing, and then you can just save it in a folder that you have defined over here. So yeah, I've got texture.png, so yeah, I'll do that. Okay, now I've got my texture in .data/texture, and I have just basically a pure orange texture. Now this doesn't change much for now, don't think so at least, can't remember exactly. And then I am going to make the vertice list, so this will be v3f, so this is 3 axes, it's vertex, 3 axes, and it's floating point numbers, so basically they're not complete integral numbers, they can be in the decimal point. And then this is the vertex data that we put over here. So you could just copy paste this and then put all the values, but you know, I prefer to do this like this. It's a lot more flexible if you want to change your positions and change your models and all that. Now I am going to do actually, let's just see if this works first of all. going to... Yes, so this should work. Just one thing I forgot to precise, that these are quads. So this will basically mean that each face, I guess, it will just split these into each of their four components. So this is one coordinate, second coordinate, third coordinate, fourth coordinate, and basically opengl will make a square out of that, or a rectangle, however you made your object. So this, if I just run this right now, then I shouldn't get any errors. What's this? Has no attribute batch. Okay. Oh yeah, this has a capital letter over here. So if I run this now, take two, I get a white screen, but there's nothing inside it because we haven't, first of all, drew the batch to our screen. So I will do self.batch.draw. So I'm going to get this variable where I put this block inside in the middle, and I didn't precise this color. I think this will be black, and I do hope that it will be black. Actually, I'm just going to show that you can put the width of the screen, the height of the screen, and that should be it. Just in case, I will put 0. Actually, this is what I did over here, and this won't work. 0.5 then over here, and so this will be orange. So even if I draw this batch and I do F5, then this will be it's the right dimensions now, and I do draw the batch, but I haven't got the actual the camera set. So that's what we're going to do right now. So now I am going to do some very complicated stuff, which is setting the 3D basically. So each time I call this, I will set the 3D. So this is self, of course. So this will basically just set the camera. Now the reason why I'm going to continuously do this is that we're going to have two-dimensional overlays on top. So that's why no. So I'm going to get the width and the height of my window, which will be self.getSize. So I'm talking about the window over here in my class. Yes, you can just do GL flush and GL finish. Now this basically just flushes all the stuff in RAM that's kind of useless. And now we probably need to put a position for the camera. So I am going to put this position at I'll just experiment with this off camera because I'm not exactly sure about these position values. And self.rotation rotation, there we are. And I'm just going to point directly forwards. Shouldn't be much of a problem. So I will import over here a new module called math, because we are going to do sines and cosines. So we'll need and tangents and stuff like that. So we'll need to import math to be able to do this. Yes, so we're going to be doing some frustum culling, and so that's I think. So yeah, but that's just I just forgot this GL depth test. Now this isn't so important right now, but this basically means that things that are behind will be hidden and things that are in front will be shown, I guess. And actually I'm also going to add self.fov, which is equal to 66.5. I think that's a good FOV. Now frustum culling is always a bit weird with these FOVs. So yeah. So this is the nearest value, so this is the nearest place to the camera that it will start clipping. And then we're going to do the distance from the top. Should be math dot tangents, let's see, self.fov, and I'll divide this by the aspect ratio, and aspect ratio is I'm going to just make this floating point so that I get a decimal number when coming out, and I'm just going to divide this by height. I think this should be it. Let me see. Well, actually, no. This should be this would be 4 divided by 4, and then here would be the nearest value multiplied by this. Now I'm going to go in depth with what all this does. So the bottom is negative value of top. So on the left, I am going to do the aspect ratio, the nearest times the aspect ratio, and then right equal to minus left. Let me see. So I fixed up a bit of these calculations. So now I'm going to do the viewing port. .viewport, and this will be So I have been doing a bit off camera, and oh wait, what happened to it? Okay, well there it is. That was a bit derp, but fine. So I'm going to set the viewport. So this is on the window. So this is a 3D viewport. Then set it up on the top, so 0. I think actually in pyglet it's at the bottom, 0, and then I'll just put it up. And so this is the aspect ratio times height. So this is basically width, it's the same thing. And then the height of the viewport. This is going to put my metric mode. I'm going to load the projection. Now this is frustum with all of these things that I've done, and actually I've forgotten to make clipping, which I'll just call this C. So clipping is the farthest distance that you can see, so I guess you could put it at like 128. So yeah, so this is frustum culling. Basically this means that anything that's behind you or that can't be seen will just not render, which is very efficient. Because in these kinds of games you're never going to be seeing much of that like that anyway. So this is going to set my matrix mode now. Once I've done this, to the model view, I am going to reload the identity, and now I'm going to do all my rotations and positioning of the camera. So I am going to make the rotation separate into some values. I do some cosines and sines and all that. You can go on the internet to see how this works exactly. And then I'm going to do the same thing with position, and in OpenGL positions are inverted. Don't know exactly why, but you have to do it negatively. So now, hopefully, set the 3D in here and all that. See? And it doesn't work. Great. So for all of you that are following along, I just reset this to 63, and let's see if this works. Please, please. No, it doesn't work. Okay. Well, maybe if I did negative. It's so complicated to just get this to work. Come on. Didn't I? Yeah. Well, I'll just be doing a bit of work off camera. Okay, I think I just found what I was screwing up on. I've got to set this model mode to static. So there are 3 types of modes in OpenGL. So there's static, which in the batch will just not move much. So this is when you're making objects that don't move. There's dynamic, which are objects that move sometimes, so these would be entities and all that. And then there's a stream, and that's objects that move every single frame. So this is just for telling the graphical card. So I have not tried this. Let's see if it works. And no, it doesn't. So another change that I've done too is I'm just going to take out this group and put none here instead, so that I don't have to work with groups or anything. And I've also tried, well, it's too late. Let's see. Yeah. Dang it. Geo quads. Right now, please work. Nope. None type object is not like no, come on. Well, after some painful trying and trial and error and stuff, I have found that I was on the wrong axis. So basically this was all correct. Come on. Can't be serious. So, yay! Now we've got a white square, which is a cube. You know, you can't really see that well. Apart from if I tried to do 10 and maybe augment this by 1 block, maybe you could see this a bit better. Yeah, that was a bit screwed up. Well, you can see a bit that it's kind of a cube. This is a bad demonstration, but I'm trying my best. If I maybe put this up to 10, I could see maybe a bit better. Nope, this has no effect. That's my color, that's why. Okay, fantastic. That's too high. This is ridiculously complicated. Yeah, there we are. Look, we've got a cube. We could probably make a bit bigger. Let's just do 1. So this will make it too wide. Yep, there we are. Got ourselves a cube. I could move it maybe a bit like this. That's way too much. That's my problem with exaggerating things so much. Yeah. So it's basically a cube. It's nothing hugely impressive. Even if this took me such a long time to get working. Anyway, I've got it working, so that's the most important part. Now let's work on the colors. So, next thing that I need to define is the texture. So I'm going to do T3F, but I'm not going to put anything in there. So I don't know, I guess this. I don't know too much how this works. I think I can just get away with doing this. I think it's T3. I'm not sure about the color. Anyway, static, so the color won't change either. And I will be doing I'm just going to be doing this. And so I'm going to make a new line. Now you can just make it in all one line, but I think it's a bit more elegant to do this like this. Okay, so color. Well, I could also just do a thing like color data. Okay, and then I could do color data equals this, and then for vertex in X range, so this is 24 vertices in my whole object, I guess. Then I do color data equals color data plus list color. So the reason why I'm going to change this into an array or list, however you want to call it, is because I can only add lists with lists, and I need a list over here, but I'm passing a tuple, so that's why. And now it should be there. It's a purple cube. Yes. Okay. So I think this will be it for today. So this is I think we've done a good amount. We've got a cube in the world with you know, a sky and all that.